Okay, section 13.2, the first half, it's on the derivatives of vector functions. And this is sample problem number 6, actually quite a complicated problem. It involves finding the cosine of the angle between these two curves where they intersect. So our first goal is going to be to find their intersection. To do that, I'm first going to rewrite the first one in terms of a different parameter so I can compare them. So I'll use 0 and u squared and u. And then the second one, I'll just leave that as t, so this will be vector b. Okay, to find the intersection point, what I need to do is compare them component by component and solve for what u and t have to be to make them all produce the same point. So 0 equals cosine pi over 2t. Well, this equation has many solutions. It limits t to be a odd integer. Plus or minus 1, plus or minus 3, plus or minus 5, and on up. It could be any odd integer, so while it limits it, it doesn't limit it very much. This gives us way too many choices for parameters. Let's look at the second component. U squared will equal sine of pi over 2t. Well, fortunately, all of these choices are only going to produce two answers. The sign of any odd number of pi over 2's is always 1 or negative 1. So this will be either plus or minus 1. Well, if u squared is negative 1, then we delve into imaginary numbers. Let's not go there. So I'm just going to get rid of the negative root. After all, we only need one intersection point. We're not looking for all of them. And I think they'll intersect when u is equal to 1. So u has to then be equal to 1. Well, let's see what point that makes over here, and then we'll see about choices for t. At u equals 1, our point A will be at 0, 1, 1. Well, let's check over here and see that this matches it. Well, clearly the z component, t can only be equal to 1 and match this point. Let's see if it makes the other two work out as well. T equals 1 here is cosine of pi over 2, that's 0. Hey, that works. And t equals 1 here makes it sine of pi over 2, that's 1. Hey, that works. So u equals 1, t equals 1 produces an intersection point. That's the intersection point we'll use to find the angle. Okay, the next step is to find the derivative of a and b at that point, because if we can locate the derivative at this location, that'll give the direction of the curves, and the dot product between them will help us with the cosine. So a prime is going to be equal to, I'll go back to t now, 0, 2t, and 1. And further, the vector A itself at the intersection point is going to use t equals 1, so that's 0, 2, 1. Okay, let's do the same thing for b. B's a little harder. B prime is going to be negative pi over 2 sine of pi over 2t. Its y component is pi over 2 cosine of pi over 2t, and its z component is 1. Once again, t equals 1, so let's plug in t equals 1, and b prime at t equals 1 is going to be sine of pi over 2 is 1, that's negative pi over 2. Cosine of pi over 2 is 0. And the third component is just 1. So there's the b vector's derivative at the point of intersection. Okay, now in order to find the cosine of the angle between them, of course, I need the dot product between their derivatives divided by the magnitude of the two derivatives. You might wonder why we're using the derivatives here instead of the original vectors. Remember, the original vectors indicated position, but they didn't indicate direction. And in order to find the cosine between them, I needed two vectors. And that's why A and B's vectors, they were vectors because they're derivatives, they're vectors that pointed tangentially, which means they indicate the direction of the curve at that point, okay? Okay, well, the dot product is pretty easy. It's 0 times pi over 2, that's 0. It's 2 times 0, that's 0. And it's 1 times 1, 1. So the sum of all these is the dot product. And then the denominator is simply going to be the magnitude. So this is going to be radical 5. And then this one's going to be the square root of pi over 4 plus 1. Pi squared over 4 plus 1. Okay, so we've got to do some simplifying here. I know if I make this 4 over 4, I can take the 4 out as a denominator for 5. So it's going to be 1 over the square root of 5 over 2. And then this guy now is going to become the square root of pi squared plus 4. It looks a little neater. And then I'll flip the 2 over. So this is 2 over the square root of 5 times the square root of pi squared plus 4. And that's what the cosine of the angle will be equal to. If you're interested, you can convert it to a decimal approximation. And of course, you can take the inverse cosine of it if you actually want to find the angle.